I guess basically that it's pretty important shit basically.
Yeah, really important. Yeah. Yeah, for sure. All right. So hello guys, and welcome live stream. Today we'll be going over what Giri went over yesterday, and that is generating permutations, or an algorithm for generating permutations, given n, where n could be the number that you want to permutate up to, or the length of an array, which is something else we'll cover. So first, I'm gonna write out the algorithm. Actually, no. First, let's go over what a permutation is. Let's say I have the set 1, 2, and 3. Can anyone tell me what's one permutation of this?
Okay, 1, 2, 3.
Yeah.
Well,
Let's say this is our universal set. So one permutation is just itself, right? 1, 2, 3, the whole thing. You want to give me another one?
3, 2, 1.
Wait, who said that? Was it you or you? Okay, sorry. All right, 3, 2, 1. Yeah. But how come these two are allowed? Because it's the same thing, right?
well, I guess maybe not exactly.
Yeah.
Yeah. No,
Why?
not exactly.
What's the difference?
Well, the order that you list the numbers is different.
Exactly. So for permutations, the order actually matters, which is why this one is different from this one. So that's one of the key things. If we were talking about something like combinations, order would not matter, and these two would be the exact same thing. So that's something very important to keep in mind. All right, we got to that pretty quick. Anyone want to give me another one of a different length, Hermes?
Just like around, like 1,
Yeah, okay.
7.
7? How did you get 7?
Ignore it.
Okay, let's just say with what you went in the beginning, 1. So yeah, so we have these two of length 3, and then of length 1, we have each single digit by itself. And of course, we always want to include an empty set. So that's another possible answer. Then the rest is just 1, 2, 1, 3, 2, 3, 3, 2, and stuff like that.
Wait, are we dealing with permutations or are we dealing with like all the different combinations? Because if it is permutations, they all have to have the same length.
No, we want to generate all the permutations, all the permutation sequences. Do they all have to be the same length? Are you sure?
They all have to be the same. Because you have like, I'm not sure anymore. I don't know. Let me Google it.
Does it have to be the same length? Oh, that's a cool sweater.
Yeah, that's when I did it with my year.
Oh, you bought it at the company store?
No, that's back when things used to be.
In person?
Yeah.
And they gave it?
Yeah.
Damn it. Okay. Dembo, you're searching it up? Okay.
If I remember correctly from this big map, you have your permutations from a fixed length, which is just like the cardinality times factorial. But then there's also like 3p2, which is your total, and then the two for the amount of values you want to fit it into.
Mm-hmm.
But my brain can't really, it's not confident about it.
Yeah, okay, let's just go with the length. Because he does do that in the algorithm as well. So let's just continue with length.
Wait, first let's see because like all the permutations have to be like 3 factorial, right?
Yeah.
Can we possibly have 6 different sets of the same length?
No, yeah, it will be greater if you do include.
So yeah, that's
Wait, so is this part? So the one with 5 choices, 4 choices, and 3.
yeah.
Yeah, okay, that makes
think
sense.
about the amount of choices too. But there's like the name of the.
It's recursion, guys. It's recursion. That's the solution.
I don't even
Yeah, but let's go with what you said. Let's just,
Class was just for the set amount, like the
Yeah.
possible amount for like.
yeah, 3.
Yeah, for just 3, like.
because like if you do it the way you were doing it, you're gonna have
More than n factorial. Yeah, you're right. Then what was I doing? What is that called then?
That
Subsets. Oh, that is every single subset. You're right. That's a different algorithm. That's what we went over yesterday. Okay, so yeah, let's just continue with the length of 3. So now let's talk another one. You gave me one, right?
No, I haven't.
You haven't? Okay. Oh, it was Paulina.
213.
Say that again?
213.
213. Cool.
Wait, which is this the permutation one?
Yeah. Give me a permutation of this.
Oh, you're gonna do the other one?
What?
Or are you just gonna do the permutation?
No, yeah, I'm just going to go over this and what he did on
You're
Thursday.
not gonna go over Actually, you can go
No, no.
Alright. You should go over both algorithms.
Both algorithms?
The one
The
yesterday.
subsets as well?
Yes.
I didn't record that, so I don't remember it.
Traveling salesperson.
It's the same thing.
Okay, but
That's network flow. Relax, okay?
you went over that.
Yeah, I know, but yeah, it's still the same algorithm.
Okay, Professor. Last
Okay, so Michael gave me one, you gave me one, Paulina gave me one, Demba gave me one.
he won.
David give me one.
You got 3 1 2. Don't say 7.
Yeah, don't say.
1 3 2. You caught me off guard. Wait, 7. That was forever.
Hermes give me one.
That we haven't done.
Yeah.
3 1 2. Oh no.
No, you did that.
1 3 2. No, we just 3 1 2. No, I just said that.
You have one left.
There's only 1. 2 3 1.
My God, dude.
You left me the last one. How am I supposed to?
You can just look, there's already 2 with 1s.
Yeah.
There was 2 or 3, so you know the next one needs to start with a 2. I put you on the spot. Okay, I'm sorry, Hermes. All right, is there anything special you guys see about this? About how many permutations we had and the length of our universal set in the beginning?
I'm just getting flashbacks to this week, man.
You're getting flashbacks?
Currently in.
Currently in. Yeah, you're currently in this, huh?
Yeah.
All right, so come up here. Give us the proof.
It's very simple. Oh, I'll leave it to you. I don't.
Okay, it's too simple. It's too simple. No need to get up. All right, so how many permutations do we have here?
6.
We have 6. And what's the length of our universal set, or do we start off in the beginning?
3.
Yeah, 3. So yeah, the relationship is that the length of this universal set, let's call it n, the factorial of that n, would tell us how many sequences there are, how many permutation sequences there are. You guys understand that part, right? Just math. Guess you know it. Okay. So how can we write an algorithm for this?
So I guess what you were saying is it's always n factorial?
Yeah. So the number of permutation sequences you would have for that length, let's say you have 3 or 4, it's just 4 factorial. So,
Oh, okay.
yeah. There's some problems, like leak code problems, where they will give you a list. They have like 1, 2, and 3. And then you want to take the length of this list, and then you want to do all the permutations with that. And then there's other problems where they just straight up give you a number like 5. Which is, there's a question like this that's really difficult. You might be able to solve it because it's pure math.
Wait, what question? What?
There's a question on LeetCode that gives you a number, and they also, let's say this is n, and they give you another number called k, and let's say this is 7. You need to print out the 7th sequence, permutation sequence. And you don't have to go through every single sequence. Instead, there's a formula or calculation that you have to do.
But this isn't the 7th index of the.
It's just a 7th sequence.
Okay.
Yeah. You gave this problem. This problem is a hard on LeetCode. Yeah.
Okay, so like when printing out permutations, is there like an order to print them out, or are they
Yep.
assuming that?
There is an order, which is something else we'll go over if we have time. But there is a certain algorithm if you want to do it ordered. You want to talk about that now to see what an ordered sequences are? Yeah, let's go over it.
Wait, so like any algorithm that works has to follow that order.
For that problem, it needs to be ordered, so you choose the correct one.
Okay.
So let's say we go back to that 1, 2, and 3. The first sequence is going to be 1, 2, then 3. Second sequence is 1, 3, then 2. Third sequence is 2, 1, 3, then fourth, 2, 3, and then 1. So there is a certain order to this. The algorithm that Giri gives, it does not follow the order. It's a little bit different. If you do want to follow the order, you have to change it up a little bit. You have to, let's see, I wrote it out. Yeah, you need to keep track through a set which number you previously added. And then let's say I added the 2, right? I go up to here. Let's say I have a for loop. I added the 2. In my for loop, I'm going to reach 1 and see if I have previously added 1. If I haven't, add it, and then recursively call the function. I'm not going to go too deep into this, but it's just something I want to point out. It's a really hard problem. Cool. So let me write out the problem that Giri did give us. He called it visit, I guess. Let's make this a little bit prettier. There we go. Count plus plus. Else. One to n. B. Cool. All right, so just starting right off the bat, is there anyone that perfectly understands this algorithm? Or is it just a little bit hard to see the recursive calls? Or misunderstands it, okay. All right, yeah, it's pretty difficult to see. As most recursion functions are. So let's actually go over it. Okay, I thought someone held the hand. Let's go over it. I'm not going to do it the same way he did it, where he actually drew out the whole stack, recursive stack. I'm just going to keep track of our count and our u, I guess. And no, our val array. Cool. So in our main function, we want to call this visit method, correct? You guys agree with that? With what do we want to call it? What do we want to start off with? Yeah.
Wait, are we going with the other arrays like 0 indexed or 1 indexed?
I think he did 1, so let's just go with 1.
Then we have to start with 1.
With 1, okay.
And then count is also initialized to 1, right?
Yeah, in the outside. Yeah, because you want to put 1 there, then you want to increment it. Does everyone understand why he said that? Why you want to start off with 1?
For what? For val?
Yeah, for calling this method, what do we want to first call it off with? So we want to do 1 because initially we want the first element in our array, which is called val. This val array is going to represent our sequence, our current sequence. We want to first start off with 1 in the beginning. So we do that. We add val at this position, at the first position, set it equal to count I guess I can write count out here as well. So we called it with 1. We set it at position 1, at index 1. We want to set it equal to count. We have 1 here. And now count gets incremented from 1 to 2.
But shouldn't it be index 0?
Yeah, Giri sometimes he likes to do it non-zero indexed. He likes to start at 0. I mean at 1. Do you guys want to do 0? Do you guys prefer that? No? No preference?
Well, either way, I don't know. Yeah.
Hermes, do you have a preference?
No, I think either way was fine.
Okay, cool. So let's just continue with 1. Currently, count is not equal to n, where n is how long you want the sequence to be. Let's say we have 3 numbers.
Wait, so the array val, like what is that for again?
So this val array is going to represent our current sequence.
Okay.
So you're going to eventually see this val array be built up, and it's going to represent a sequence for all the permutation sequences.
It's still a little confusing, but
Yeah, Dumba?
I think I don't know, but correct me if I'm wrong, but I think there's an error here because if we go with one base indices, right? Like let's say we're permuting 6, right? At 5, when it stores 5, it will be 6, right? And then when it reaches the if condition, it's gonna print out without actually ever having to have stored the 6th place inside the val array. I don't know if that makes sense.
So if our val array was initialized to 3, 1, 2, 3. If we get to 3, you're saying we're never going to store 3?
Yeah, I'm saying at 2, after storing 2, we're gonna print it out without.
Oh, yeah, you're right, because it's increment. Did I copy this wrong? Oh, I did copy it right. That's what if n was not 3, but it was 4?
Okay, so at 1, we will store that.
Hello.
So at that first iteration, we're gonna store 1, right?
Yeah.
At the second recursive call, we're gonna store 2 and then increment it to 3, right? That is still not equal to n. So that's that recursive call, we're gonna store 3 and then increment it to 4, and then if it hits the if condition, it's gonna print out without ever storing the 4th value. Do you see what I'm saying?
No. So let's say our n is 3. So we only want to store 1, 2, and 3, right? That's the sequences we want. But we do, when it's equal to n, instead of making it equals 3, if it's equal to 4, so 1 greater, then we know we can finish.
Then it will work. If
Yeah.
that's the case, or we could have moved that plus plus to be behind.
Yeah, we could do it like after this or something. Yeah, I'm just gonna leave it that because I don't want to resolve this. Okay, cool. So, Michael, let's work it through. Let's see how we can make sense of it, right?
okay.
So our val array is initialized with 3 zeros in the beginning, correct? Yes, for this problem.
Okay.
Because we want to
yeah,
find all the permutation sequences of 3.
Okay.
So we call this with 1. We call this visit method with 1.
Okay.
So u is equal to 1. At position 1, which is right here, let's set that equal to count. And count initially is initialized to just 1.
Okay.
So now this array gets updated, and there's a 1 here. And this gets incremented.
Oh, okay.
Count is not equal to n. So we know we have not finished. We still have to build it out a little bit more. So we reach this for loop.
Okay.
In this for loop, from 1 all the way up to n, we want to check which position in our val array is empty. Like which index have we not added a value to? Which one is it? You guys want to tell me? Which one is missing a value?
The second one?
Exactly, yeah, the second one. So when v is equal to 1, it's not going to work. Because value, the elements at index 1 in the value array does not equal 0. It equals 1. So it's going to run through one more iteration. And then when v is equal to 2, it sees that it is equal to 0, and we're going to recursively call this function. So we call visit one more time, but u, instead of being 1 now, it's 2. You guys are with me so far? It's going to get pretty confusing.
Started the rate of
Yeah.
n0.
Yes. Yeah. Cool. So let's call it. Now we just called it with 2. So now u is equal to 2 at position 2. Let's set that equal to count. And then let's increment count. You guys still with me? Okay, cool. Count is not equal to n. So we can go back to this for loop. When v is equal to 1, value at index 1, it's not equal to 0. There's a value we've placed there. So we continue. We look at 2. That's not empty. And we look at 3. 3 is empty, so we can call that position. We call visit again, but now our u is v3. And then in here, we can put count, but then increment count. Count is equal to n, so we just want to print the permutations. Do you guys agree that this is one permutation?
Well, first, so you say at this point count equals n, but count is 4. Well,
Yeah, so let's just say n is equal to the length of value plus 1. Oh, actually, it's just going to be 4. So instead of it being 3, it's 4.
so wait, n is length of value plus 1?
No, not plus 1. Do you know Python?
Oh, okay.
Yeah, so this makes it, actually no, yeah, it is plus 1, sorry. This will make it 4.
Oh, okay.
So what did we originally pass for all these permutations?
Yeah.
What numbers did we pass first? Just dynamically adding, or just
So initially we're going to start off with u is equal to 1. So we want to first look at this position right here.
And when does this loop exit?
It exits, for example, once we build out all the permutations, that's when everything finishes. Because this 1 is going to travel. This 1's going to be first placed here, then here, and then here. Then after that, that's when it completely finishes.
So would that, because there's no more position I see right here for one.
Exactly.
So that would like not, okay.
So yeah. So currently, for now, there is no more positions we can fill, which is why we print out the permutations, and then we skip over this for loop, and we go to these 2 lines right here.
Actually, a question. So, I don't know. So is there a way that we could do it like without having to use like u and v? Like I see we're using like 2 variables kind of. Like down there we use v, but up there we use u. Why can't we just use like u for the for loop?
U here?
Yeah, that's what I'm asking.
Yeah. So this v represents the current number we're looking at in this iteration from 1 to n. So we can't use u because then we'll be overwriting it.
Yeah, like you would only be looking at from a limited amount.
Yeah.
V is supposed to be like your local variable for that loop specifically.
Oh. Because I guess what u is I guess I'm trying to see like why it would overwrite it. Well.
Okay, so let me see if I can give you an example.
U is the current position and
Yeah.
the rate, right? And then V is looking for the next position, right? So you don't know what the next position is going to be. So that's why you need another variable to find it. You can, if you reuse U, and that happens to be
very
another
cool.
position, it would overwrite it.
Okay, so let's continue working this out, and you're going to see why we need to use u and v, and we can't just use 1.
Okay.
We're going to get to a place where we're going to have 1, 0, 2.
Huh. Okay.
And from there, like, it would make sense. So currently it's filled. Count is equal to n. We want to now decrement count. Change it back to 3. And then set this equal to 0. So that stack call, that recursive call finished. The call where u was equal to 3 is now complete. And we backtrack to when u is equal to 2. Does that part make sense?
Wait, what do you erase 3?
Yeah. Yeah, exactly. So it hit this case,
Okay, so it's back, okay.
but it didn't hit the else. So we did these 2 lines.
Okay, cool.
Cool. So this is also going to finish. When u was set equal to 2, v was in this position, correct? Do you guys agree with that? Yeah? Okay. Do you guys know why?
Wait, sorry, can you repeat that? You said when v was set to.
When u was looking here, when u is 2, we did this for loop, correct?
Okay, okay.
And the for loop only did a recursive call when v was there.
Hmm.
Do you see that?
Are we running
Okay,
back?
so when v was there, okay. Oh yeah, then it recursively called visit again.
Yeah.
Okay.
Would it go back into the loop again? Since they incremented or no?
Yeah. Well, it will go back. Yeah, we'll go back to the loop, and we'll go back when u was at position 2. But now this loop would finish. It would terminate.
Because the last, the
Yeah.
negation one is 0, that's why.
Yeah, because we called it here, but then we incremented v. But v was done. We already did this whole range. Everyone good with that? Yeah? It's pretty difficult to see, huh? It's hard to explain. Kind of sucks.
Maybe you have a stack.
Yeah, I was, man, Giri did the stack call. He did the recursive stack. But I didn't know if that would actually really help you guys. So I was trying to do it with just these variables and updating it sequentially, kind of like this. But now I don't know if it's really working. I feel like it's harder to see. What do you guys think I should do? Should I do the call? Should I do the recursive stack? No? David is saying no. Are you guys having issues understanding this so far?
No, my brain also understand the version you wrote us with the trees, but
Oh, yes, the trees.
I don't really understand.
Damn, the trees is smart. Trees is actually pretty helpful.
In this case.
Yeah, because it's just recursive, and the child node will be like where u is at.
Wouldn't that be like where it's visiting the child and knows that?
Yeah.
Oh,
So like every single node will be a different u.
1, 2, 3, 4, 3.
You know what? Let's do that. Let's do the tree. That might help you guys the most.
We do 1, 2, 3.
It's gonna be a big tree though.
It's not gonna fit on the thing.
Oh, crap. God. Why is recursive so annoying?
Just do 3.
Yeah, I'm doing 3.
Actually, maybe you can
6.
use that one.
Yeah, true. Worst case scenario, we can use. Yeah, actually, yeah. Let's just start off with there.
Wait, like if you use a tree, like I guess like with 3 variables it's possible because you don't have to make a recursive call for every iteration in the code. It's just when it is 0.
So you can look at a stack, like a recursive stack, the same way as you can look at a tree.
No, yeah, I get that, but I was just thinking like how big the tree would be.
Oh yeah, here should have 6, right? 6 leaf nodes, because it should represent 1 for each sequence. So it should still be n factorial. I guess we'll find out. All right, so let's start off. Let me get a better marker. Huh? They actually can't. So I'll do it here, then I'll move it. There we go. What? Oh yeah, they are. So let's keep track. We're starting off at 1. Yeah, because I want to show you guys both the algorithm and this. At here, our value array would be 1, 0, and 0. This part we've been over already. We're calling it with 1 at the first position in our value array. Set that equal to count. Count here, set to 1. So count is not equal to n, so we're going to hit this for loop. The branching factor might be big though. Cool. So it's going to go from 1 up to n. At 1, it is not 0. So we do not call it recursively. At 2, there is a 0 right here. So let's call this function recursively. But now we're going to be passing it 2 as u. So u is now 2. Count is 2. 1, 2, and 0. Make sense? Cool. Now this 2, it did this part already, as you can see right there, because at position 2, it set it equal to count, which is 2. Then it hits the else. It goes through the for loop one more time. It's going to check if at index 1 is there a 0? There isn't. How about index 2? There is not. How about the third index? It is a 0. So we have not yet updated that position. So let's do that by recursively calling this function. We pass 3, because that's what v was before. So now u is 3, and at the third position, set it equal to count. Count is now 3. 1, 2, 3. And count is equal to n, so let's use permutations. So this is one sequence in itself right now. When this terminates, it's going to decrement count with this minus minus, and it's going to update that position to 0. So we're going back here. That part makes sense? About why we moved up one more to the parent node? Cool. It's the same thing as, because this is setting equal to 0, and then the minus minus, this gets changed to 4. So here, once we go back, instead of being 2, it's actually 3.
Wait, repeat that again. Why did
Yeah.
Because it just said value u equals 0 and you gotta count that decremented it.
Yeah. So once we reach this 3, it's going to put 3 in the third position, which is our u, but it's also going to increment count.
Right. 4.
So here our count was initially 3, but by the time it finishes, it will be by the time it puts it into this array, it will be 4. Then when we get here, it's going to change it back to 3.
Oh, okay.
If you want, I could be a little bit more consistent. I can change these to 2.
Yeah, it's like saying the if statement, if it's n, you print the permutation.
Yeah.
You decrease the count, and then you go back to 2 and 3.
Yeah, yeah. So, all right, replace 3 there, and we increment it. So let me just call this 4. And then we decrement it. So now it's back to 3. So there we go. And then this is already 3 there.
And then you just go back again and make the 2 become 0. Oh, okay.
Yeah, so when we get back to here, v was currently at 3. And we know that because we called the function recursively at 3.
Yeah.
But now, this for loop finishes, because there's nothing else after 3. It goes from 1 to n, and n is 3. So it finishes that. We decrement count, go back to 2, and we set val at u, which is 2, to 0, which is this right here. You guys see that? Okay, cool. This is so much better. Thank you. Yeah, Pauline?
So the permutations right now is 1, 2, 0.
So the permutation right now, no, the permutation right now is this one, because this is one we printed. And we only print it if this if statement gets triggered, and this only got triggered at this node. So once we travel back up here, our v for when u was 1 was 2, right? You guys see that part? Because that's why we called this 2. Cool. So it has one more room, one more iteration to go through. Instead of 2, now it's going to go to 3. So it's going to pass 3 to visit. And at position 3, it's going to put count plus plus. 2, then 3, position 3, 0. And then this will be what, 2? Yeah.
Wait, what just happened? Why do you have another, like, a meeting? What's going on?
Which one?
The one that 3 just made.
This one?
How that came from?
Yeah, so we're going back to the beginning when u was equal to 1.
Mm-hmm.
Remember we were in this for loop?
Mm-hmm.
When v was equal to 2, we called visit. That's why we got this node. And then this 2 in itself went through this for loop and called 3. But then this finished, so that backtracked to 2. 2, I already called 3. There's no other iteration in the for loop, so it's going to backtrack once again. This 2 finished off at v is equal to 2. Now, since we're going from 1 to 3, it's going to try v is equal to 3. So v is equal to 3. Is there a 0 there? There is. So let's call visit with 3, which is that node.
But like, I get why you went the backtracking part of it, right?
Yeah.
Why did you get the rate from 1 to 3? Is it because of the length of the amount of value that you had before when you went all the way down to 3?
Wait, I'm sorry. Where do you get the what?
Where do you get the 1 to from the range v 1 to still the range you got 1 to 3?
Oh yeah.
Where's that 3 coming from? Is it coming from like the top of the?
So this n is a global variable, and it's just set to 3.
It started.
Just looking at an example of permutations of three
Yeah.
numbers, of 1, 2, 3.
Okay.
So
Yeah.
you're just doing the example of 3 numbers. So that's why he's setting it to 3.
Oh,
But
okay.
it
Yeah.
could be any number hypothetically.
Yeah, exactly.
Okay. And then you created this like a leaf right here is 3, right?
Yeah.
This leaf just came about from where the value was 2 before.
Yeah, it was 2 before, which is why I called this 2 right here. But now he's going to increment 1 more, because it has 1 more iteration to go through.
And that's why it's 3.
And that's why it goes to 3. Yeah, yeah.
Yeah, I think like the for loop is like, it gets you a little tripped up because
Yeah.
it's like you call it,
Yeah.
and you backtrack, and you have to call it again, and you kind of forget that that's what you were originally doing.
Yeah, all this backtracking, man. Dude, recursion is bad, but when you add a for loop in recursion and you need to explain that, fuck. Yeah.
Okay, then we do 2 after that one, right?
Yeah, exactly. So now we're here, right? Everyone's caught up? Michael, any questions? No? You're good, Michael?
You know what? Sorry, it's just.
No,
like,
it's fine.
okay,
Ask
what
questions.
about- so I don't know. I kind of get for one thing like why we backtracked, but like as far as like the part of the code that's doing it, so I guess what was n at that point? So you know how we have if count equals n, we print the stuff. So we jumped like to the bottom because.
So for which node are you specifically talking about?
So like when we got down to like 3.
Okay, perfect. So when we got down to 3, u was equal to 3. You get that part?
U is 3. Okay.
Yeah. And count was previously 2. Wait, no. Count was previously 3.
So count is 4 at that point, right?
Yeah. So we add 3 to value, and then we increment count. So in the array, we want to add our 3, and now count
Okay.
is 4.
Okay.
At this time, we said that, oh, count is equal to n. So let's print the permutations. Print every element inside of this array. That's what that means.
Okay.
And then, since we hit the if statement, we're going to skip the else.
Oh, okay.
Then go down to count, decrement count from 4 to 3,
Okay.
and then set the value at 3 equal to 0, which is the
Oh,
same thing as backtracking up here. So we're going to do that, and then we're going to backtrack.
Okay, okay.
Once we got back to 2, you agree that u is equal to 2, right?
U is equal to, wait a minute, u equals 2?
Yeah.
Okay, yeah.
Do you want me to start from the beginning?
Oh, okay, wait, I guess u is equal to 2 because, at that point count was 2. Is that why u is 2? No.
Okay, so in the beginning we started off with 1, right?
Mm-hmm.
So we initially called this with 1. We hit the for loop, and then we're going from the ranges from 1 to 3,
Okay.
right? So v is going to be 1 initially, and then it's going to check if in the first position, is it a 0? It's not, it's a 1, right? So now v is like, hey, 1 didn't work, let's do the next iteration. The next iteration is when v is equal to 2. It's going to check if at position 2 there's a 0. There is.
Okay.
So since there's a 0 there, it's going to recursively call the visit function. And it's going to pass 2 as u. So when we call this again, u is now 2, as we have right here. at position 2, set it equal to count, which is 2.
Uh-huh.
And then increment count plus plus,
Okay.
which makes it 3 now.
Oh.
Count is not equal to n, so we do not print. Instead, we hit this else statement. And now we go through this range again. V is equal to 1. Is the element at index 1 0? It's not.
No.
We go to the next iteration. V is equal to 2. Is that a 0?
No.
No. Perfect. V is equal to 3. Is that a 0?
Ah, yes.
There is, right?
Uh-huh.
So now we're going to call visit again, and we're going to pass 3. So when we call it again, u is 3. At the third position, let's set that equal to count, which is
Okay.
3.
Okay.
And let's increment count, so it goes from 3 to 4.
Oh, okay.
This 4 is equal to n, so let's print the permutations, which basically says, hey, let's go over this array and print all the numbers. So it hits the if statement and skips the else,
Okay.
the else block. Now it's going to decrement count, so it goes from 4 to 3. And at the third position, it changes it to 0.
Okay.
From there, we backtrack, and we have this. We have 1, 2, and 0.
Oh, okay.
So here, remember that when v was 3, we called this recursive function, right?
Uh-huh.
So after that, once we come back, once we backtrack, this for loop finishes. That part makes sense? There's no more iterations for the for loop to go through. Because we initially
Okay.
paused at 3
All right.
and called the function. So when we come back, there's no more iterations left.
Oh, okay. Okay.
So then there we decrement again and set it equal to 0, which we get this, 1, 0, 0. And we get count equal to 2. So now we backtracked to 1. This is really confusing. We backtracked to 1, and at 1, we left off at v is equal to 2. So we have one more iteration to go through, right? The iterations that we have to try now is v is equal to 3. Is going to check if at the third position there's a 0, which there is. So it's going to call visit with 3. There we go. So now this is 3. And at the third position, it's going to be set equal to count. Remember, we decremented count. So instead of it being what we had here, 4, we decremented it. It's 3. Now it's 2. And then here, we set it to 2. So now this third position, there's a 2 there. And count gets incremented, plus plus, of course. So now count is 3. So with with u at 3, count is not equal to n. U is just 3. So we hit this else block. And we go from the ranges 1 to n again. At the first index, is there a 0? There is not. We try the second one. V is equal to 2. At the second index, is there a 0? There is. So let's try that. Let's call this 4, I guess. Oof. Yeah, no. Yeah, 2, 2. Thank you. 2. Because that's what v is currently set equal to. This count gets incremented to 4, and now our array is 1, 3, 2. And then it's going to hit this if statement, and because count is equal to n, and it's going to print the permutations. It's going to skip the else block, decrement count, go back here, and then set value equal to 0. So now there's a 0 here, and we go back. It's the same thing as backtracking, and we're left with this array and this count. Is this making sense? Does a tree help?
Yeah, I think what you might have helped is doing like a little stick kind of showing like a null, like you can't do anything more with the loop. You get what I'm saying?
A stick, you can't say it.
We can't do that because
Like,
we're going off count. That's when we stop.
No, it's in okay, hold on.
If you're saying that like you know, there's a point where we stop the recursive call,
Mhm.
right?
Oh, that's what. Oh,
But there's like an add, he said that because there's an adding function that doesn't care about the loop. It's always gonna have it as a recursive call, right? Is it because like there's an adding
think
function,
like- I don't think
recursive
there's
call?
like-
so
Yeah,
it's
yeah,
gonna be
yeah,
like-
count
going
plus
about
plus.
it.
Yeah,
It's like a
Yeah,
counting
if
call.
the count equals
yeah.
one,
I don't know how to simplify anymore.
right? Then
Yeah.
you don't run that recursive call in the for loop.
It was outside, it'll
Maybe
always have
keep
it
track
until-
of V.
Yeah, exactly.
And
A
then-
V?
Yeah. I don't know if that would help. I mean, like you are keeping track. Of
Yeah, so might as well add V.
Yeah, I think keeping track of these is what you're missing actually. He has a good point.
Okay,
What
so
you
let's.
do is what is written on top, right? You know where the
Wait, what
position.
Yeah, this is count. This is val, and then this is u.
Oh, okay then.
So yeah, okay. Let's add v.
You also might want to annotate the with like the
Yeah, with a different color.
with another color marker.
Okay, let's do that. Let's do that.
Aren't you into local variables to the?
Yeah, yeah.
And one more suggestion, maybe like you know how you have the count, like there's like a little inconsistency between like the count when it stops at 4 and the for loop stops at 3. I don't
So-
know, like maybe we 0 index it instead of 1 index it.
I did here, so I didn't want to confuse them. So n is still equal to 4, but in Python this is exclusive.
Oh, that's like also
Yeah.
the same thing.
Yeah.
So this is 1 to 3. That's what it
Yeah,
is.
so it is still going over the range of 1, 2, and 3.
Okay.
Okay, cool. So let's keep track of v. You guys want to fill it in for me to make sure we understood this?
Don't sacrifice me. We gotta go. That's all. I'm a new person.
Alright, so V is 1 for the first recursive call.
Oh crap!
So like that.
Unfortunate. Does this fail or succeed?
It succeeds. What do you mean by fail?
Like, is this going to call the visit at 1?
No.
Yeah, it's not. 'Cause
Wait, but it, hold on.
We're
No, it's not gonna call this.
Yeah.
It's gonna move to 2 here.
Yeah. So this fails. What's the next v? Someone else, please.
That'll be 2.
2. Does it fail or succeed?
It failed.
Fails?
No, it succeeds.
Wait a minute. Explain.
Yeah, it succeeds because there's no.
Because it's calling the recursive function now because val v is equal to 0.
Oh, yeah.
Yeah. So this succeeds. Now we call 2. U is not equal to 2. It hits the else block. It runs this because it fails at the if. V is 1. Does it fail succeed?
It fails. It's
Yep.
1.
Yeah, it fails.
And it goes to 2, it's gonna fail.
Yep.
It goes to 0, which is to be 3, which is gonna succeed.
Is it going to go to 0?
No, it's gonna, the index gonna be 0. It was gonna increment to 3.
Okay, yeah, it's going to go to 3, and then it's going to see that it's 0, and it calls this. Someone else, except you two guys. What is v going to be here? Paulina, all yours.
It doesn't go in.
Perfect. It doesn't go in because it hits the if. It doesn't hit the else. So here, we can just finish early. Then we can go back. 2 succeeded, but we're done with 2, so I'm just going to do an underscore. I'm going to represent it as it worked, and we're finished with it.
But then 3 does go over like 1, 2, 3, and then it fails all of them. So you backtrack, right?
Wait, what? Sorry?
Like when you called it for 3, V, it went over 1,
Yes.
2, and 3, and then
Yeah.
it failed. So you backtrack it.
Then here it failed all of them.
And
Yeah,
then it
so now we
also
backtrack.
failed at the 3 over there. Like the 3 at the
Yeah, it failed 3 at here. It only succeeded at 2 here.
So,
Wait, I'm confused. We just continue. Like I'll figure it out as we go.
Yeah, yeah. Let me know. Let me know.
Clip. What is happening.
Yeah.
so those numbers that you wrote in red, like above the thing, like 4, 3, like those that you wrote, like yeah, that 4, that 3, I guess that's the count. then,
That's
right?
count. Yeah.
Oh, okay.
Yeah. So we're back at 1 now. 2 succeeded, but we haven't finished. We still have a 3. So let's try 3. Does it succeed? Michael, does it succeed?
Okay, it's a 0, so
Bingo. Yeah.
Yeah.
So it does. So that's why we go down here. Let's do the for loop for this. You want to tell me?
Go ahead. There we go.
Yeah, just tell me all of them.
What happens
What did you say?
Oh, you want to tell me like the V values, like succeed or fails?
Right?
So is 1 going to succeed?
So if you go to 1, it fails because there's already a value there. But then when you go to 2, there's a 0.
Cool. All right, yeah, that's it for now. All right, what here, Demba? What are will be the V's here?
You called it for 2, right?
Yeah.
Something is in 2?
Huh?
Is 2 a 0 or is it?
Oh, my
does
bad.
it have
I'm
a
sorry.
two? Okay, yeah, so it also fails, so it reduces the count by 1.
Exactly. It doesn't hit the else block. It doesn't hit the else block. So there's no need for V's. It
Sets 3 to 0.
runs the if. Yeah, and then sets it 3 to 0, so we're back here. So 2 worked, and we're done with 2. What's the next one?
3, right?
Yeah, 3, 3. No, that's fine. Fail, succeed.
Fail.
Fail. Because there's a 2 there. Cool. So what now?
It should go backtrack.
Okay. So it's going to go backtrack to what?
2. No,
It's going to decrease the count and make it equal to 0 because you already finished the for loop.
So we finished this for loop. We decrement count. So it went from 3 back to 2, right? And we set that position to 0. So we're back here, right? What now? Let's see if you guys can figure it out.
And then you decrement the count to 1.
Okay, we decrement the count to 1. You're totally right. So I'm just going to do this.
Because you already finished the first for loop in the first case, so like,
Exactly, yeah.
and then your value at 0 is going to be 1, so you now have 0, 1, constant 0, yeah, 0, 0, 0, 0.
Well, we done?
That's the one part that confuses me about this.
Okay, good, good.
So
Like-
what I'm thinking now is like, this is called inside of for loop, so you have to like probably move. Like you have to like call it, you know how you call it fixing 1, starting from 1 being the parent.
Yeah, you got it.
Call it with 2 being the parent. and
Exactly.
3 being the parent.
So in the main function that starts off this call, remember how we began at 1? It's not just going to be visit 1. It's we inside a for loop. For v in
You might
Good
wanna
job.
change being one of them
Huh?
into a different, instead of
Oh, sorry, you're totally right, yeah.
like,
There we go.
no, you might, if I'm understanding you correctly, you're saying visit, put it in an outside loop that generates all the possible permutations, right?
So this is be the main function, and this main function is what caused this.
Yes, okay. I get you, but I'm saying it probably is confusing to use V, because V is also using.
Oh, okay. So let's do like A. That's better,
Is it the main function of the whole entire?
right? Is that what you're saying? I'm sorry.
Yeah, that's what
Okay.
I'm saying.
What is this? Is that the main function of the whole entire like permutation thing? What is it?
Yeah. So this is the function that starts off this call.
Oh, okay.
It's like fixing all the first digits first and then moving.
Yeah. So yeah, you can think of it as that, as moving this this first one up and up and up.
Fixing the first one and moving the rest.
Yeah, and then the rest will fall into place with this recursive calls.
Now it makes sense why you would have like
Yeah.
what you were talking about, a sequence.
Yes.
I wonder this thing was confusing the living hell out of me, because I was like, okay, I get how you get like 1, 2, 3, I kind of roughly get that, but what
Yeah.
happened with the moment you finished with 1?
Yep.
At the node.
Yeah. So this is a very important part. If not, you will only have these two.
Yeah, so that would that be the combinations? No, I know, that doesn't.
Yeah, no, because these are this will be the same one. Yeah. So can we all agree that this is when A was equal to 1 to 1? Would you agree that we have another different tree down here where A is equal to 2? You okay? You have a question?
Okay, I'm just thinking. So you kind of lost me a little. So this part about for A. Oh, I guess you're using this for loop for What's that for loop for?
So this, you program in Java?
Okay, yeah, I know
Okay.
Java.
Crap. Cool. So, so think of this as your main function, right?
Your main function.
Yes,
Okay.
this is your huh?
It's a method.
Yeah, think of this as your main method. This main method is the only one that makes calls to this. The first call we make is with a at 1.
Okay.
Once we call this at a at 1, it's going to do all of these, with all these backtracks. It's going to give us these sequences, right? But then once that finishes, it's going to decrement count back to 1, and it's going to set every element inside of val to 0. So you can think of it as another backtrack here. Confusing?
Okay, you know what? Sorry, I don't know why. I'm like very confused right now. So you wrote that one. So you say it's like the main method, I guess.
Yeah.
Like
Yeah. This is what caused that.
so the A is
A is going to go through A of 1, A of 2, and A of 3. So we did A of 1 right here, which is why at the first position we started off with 1.
okay.
Now, so that's going to finish. Now we're going to do A of 2.
Oh, okay. Okay, I think I'm seeing it now. So right, every time you call visit A, it's basically like calling the whole function
Yeah,
that we wrote over
yeah,
there.
exactly. It's calling that, yeah.
Okay.
So this is what we're calling that visit.
Okay.
Okay. Okay, cool. So now, let's do when A is equal to 2. You agree that oh crap, now I'm blocking that. This is so complicated. Okay, you agree now U starts off with 2, right? Yeah, you guys agree with that? Okay, cool. So what does that mean? What's my val? How is it going to be changed?
Well, it starts at 2, and it goes to like if statement.
So yeah, so we're going to index at 2, right? And we're going to set that equal to what? 3?
Wait, you incrementing right now?
No, remember we fully backtracked, so we're all the way out here. So now count is reset back to 1, and our val array is all zeros.
Oh, okay.
So what is our count and val going to be here?
1.
1, where is that 1 going to be?
So the first at 0, the first index, right?
No, not at 0.
No, the count is incremented to 2, but then you put the 1 at val u, which is in this case 2.
Exactly.
Which is what you're visiting, right?
Say that again?
Is that what you visited, or?
Yeah, first you put the value in the array and then you increment it. So I think that's what's confusing you. So right now,
Yeah,
your
you
count
put it.
is 1, so you put it in the array where your u is equal to 2, so then it's in the middle. And then you increment the count to 2.
Oh, because we're starting at 2, so like the second number is 1 when you start the. Oh,
Yeah, exactly.
And then the count starts at 2. Okay.
Yeah, so count is 1, so we set at the second position, set it equal to 1, and then increment count. So it changes from 1 to 2.
Right.
Yeah. Because remember, we went back to this for loop.
Oh, okay.
Let's talk about V's. All right, someone want to give me the V's? Anyone want to give me the V's for this one?
3.
Not exactly.
V equal 1.
Succeed or fail?
Succeed.
Yeah, exactly. Because at 1, it's a 0. What is this going to be now?
3. Wait, you can read it right now.
Is it 3?
1 is 1.
Yeah, 1.
You go visit 1.
What's going to change in our array now? And then the second one doesn't change. What's going to be count?
And then you call the loop again.
Yeah, but count is we change to
Oh,
3.
sorry.
Yeah, that's fine. You're okay? Yeah, does it make sense?
Yo, repeat that again. Like
This part?
No, before. Why did it go to that point where I know it's one of the thing we started from the outside.
Yeah, because remember, U is at 2. So the only element we have is at index 2.
It was just one. That's why.
But our for loop starts at 1. And at 1, we have nothing.
Okay.
So since at 1 it is equal to 0, we call visit with 1.
Oh, and that's why that child is one. Okay.
That's why the child is 1, and that's why we put a 1. Sorry, that's why we put a 2 in the first index.
Oh.
At index 1.
Okay.
Yeah, whenever you like visit a like a number, it doesn't like continue. It starts from 0 and then searches for all
Yeah.
the first 0 that it sees. That's where it goes.
Yeah, that's
Okay,
for loop is
yeah,
always.
I know that visit that one. Oh, okay.
Yeah, yeah.
Okay.
So the for loop is always going to be from 1 to n. All right, so someone want to give me the v's for this one?
You go 1, it fails. 2 fails. 3 doesn't fail. So then you call visit 3.
What's going to be the array now?
Can I borrow one of those markers?
Yeah, go for it. So what's going to be the array now?
3.
3 is where?
At the beginning of that, right? No.
No, not, yeah, exactly. So it's be 2, 1,
3.
and count goes to 4. Anyone want to give me the v's for this one?
We have to back
We
that,
don't
right?
have to.
Exactly, exactly. You guys got it.
The if statement gets there, so you never hit the else.
Exactly. So there is no v's for that one because we don't hit the else block. We hit this if block. So right here we're done.
Permutation, right?
Yeah, so we just print the permutation. We print 1, 2, 3.
So even if you did hit the else, it doesn't make a difference.
Huh?
Even if you did hit.
Yeah, even if it did, because since all these values are filled, it's not going to run it, and it's not going to call another recursive call. That's how Giri had it in his lecture, but he said to adding the else is better might increase your speed, because you don't have to do this unnecessary for loop. So big O notation doesn't really matter, but
What is orientation for this one?
crap, is it n factorial? Yeah, it is n factorial, right?
I think, yeah, he said it in class. It was
N factorial, okay,
It's n factorial.
cool.
This is class.
Algorithm techniques.
I should take- well,
Okay, so we're done here. Decrement count, it goes from 4 to 3. And now at position 3, change it to 0. Same thing as going back here and with these counts in this array, correct? So this 3 succeed or fail? Succeeded, of course, but now we're done with it. So now what? Say it.
You backtrack.
Yeah, you
I
backtrack.
said everything now.
Yeah, so we reached 3, and remember our for loop goes from 1 to 3. So we're done. Now we reach these 2 lines, decrement from 3 to 2, set the 1 at the first position to 0, which we backtrack, and it's this. So here we left off with v is equal to 1, right? We're done with that. What's the next one we're going to try? 2, exactly.
But then it fails.
Exactly, because 2, at 2, it is not at 0. But now we are going to try 3.
3 to 0.
Exactly, 3 is a 0, so that one is going to succeed. What's our way going to be?
Wait, 0,
Correct.
1, 3, right? No. 3. Yeah, 3.
You sure?
For sure.
What is that? Wait, hold up.
Wait, what do you say?
2 is.
Yeah, it is going to be true.
Oh yeah, that's why this is the last count.
Oh.
Exactly, yeah, yeah.
I was looking at like the one above, and I was like, isn't it 3? And I was like, oh
What
wait, no.
was the last one I counted?
So you can see it this way. We're trying 3, right? So when we make the call, at that third position, we're going to set it equal to this count.
Oh, okay.
So that's why at the third position, set equal to that count too. And then increment that count. Cool. So what will be the v values for this one? Wait, Michael, you tell me.
Oh, the v values.
Yeah.
The v values. Oh fuck.
If you're not paying attention to this, you
True.
easily like forget what's going on.
Yeah, 100%. So we just called u with 3.
Okay.
We already did this line because in the third position we said it's equal to 2, right?
Uh-huh.
Is it going to hit the if or the else?
Wait, it's okay, so let me see. Count equals, so I guess we need to see this. Count equal n.
N is 4, count is currently 3.
Okay, so we do enter the else.
We enter the else, perfect. What's going to be the first v value?
0.
If you look at the range, it goes from 1 to 3.
So 1.
Exactly. Now we hit this if, right?
Okay.
At the first index inside our vowel array, is it equal to a 0?
No.
You sure about?
Wait,
This is
yes,
1,
my
this is
bad,
2,
yeah.
this is...
Yes, yes.
Yeah. So it is, so we're going to succeed. And we want to pass 1 here. So now what is our array going to be? So this passed. Now we want to call visit with 1. So we're calling visit. U is now 1. Value at the first index is equal to count. So what are we going to put in the first index?
1.
Not necessarily. This part might be confusing because you need to... Yeah, it's going to be 3. Yeah, because previously we incremented count to 3. Right? So count currently is equal to 3. We call this recursive function, and at the first index, we put that 3. So now we have 3, 1, 2. This gets incremented 4. What are the v values for this?
None because
Yeah. Yeah, both of you and Paulina got it. Well, you and Paulina, not both of you and Paulina. So yeah, so it's just going to print this out. And now we're going to backtrack, decrement, of course, and then set it at the first, set it equal to 0, which we're left with this. Same thing as backtracking. 1 succeeded. Now let's try 2. Is 2 going to succeed?
Fail.
Perfect, fail. Is 3 going to succeed? No, perfect, fail. Now we backtrack to where we started, correct? We just finished 3. It succeeded, and we finished it. So we're done with the for loop. Decrement count. Count goes to 1. And then change our vowel array. Where are we going to go now?
To the 1, to the range.
Perfect. So we just did 2. All we're missing is 3. Should I do the third one, or should I leave it up to you guys?
I think you just need to do the first two to kind of get
Yeah, the pattern. Okay,
pattern.
perfect.
But at first, you see the big the main the for loop in the main one, and you're like, I don't believe you, and then you have to see
Yeah.
like, okay,
Yeah.
I believe you. And
Or just like in the Discord?
Huh?
You recorded it in Discord.
So yeah, it's actually on our YouTube channel. I put the link to the video. So as soon as I stop the live stream, if you click on the link, you'll be able to see the video.
Okay. I don't know which channel on the.
It's called Interview Training.
Okay.
Yeah.
Okay.
you just look up FIUDSC.
No, I'm in there. I'm inside.
Yeah,
I joined it
sure.
recently. I just don't like look at it because I always have other stuff.
Oh, yeah.
I'm gonna start coming now.
Oh, I appreciate that. But if you go to YouTube and you search up DSC FIU, it should be the first one.
Yeah, mine is I didn't know if you meant the channel inside Discord or the channel inside you.
Oh yeah. Yeah, it's we post on both. Every time there's a live stream, we post it on both. So this is the general pattern. Thank you for suggesting the trees, and thank you for suggesting adding the V's. That rhymed. Trees, V's, cool. I think it helped. Do you guys think it helped visually? Perfect. So yeah, hopefully this helps, and hopefully you guys understand how the algorithm really backtracks and builds out this permutation sequences. If it didn't, try to work on it a little bit more. It's usually hard to understand backtracking, but if you really build it out like this, you can really convince yourself, and through practice, you'll be able to understand it even better. So unfortunately, I'm out of time. But there's a whole bunch of other cool stuff. Maybe we get to go over it next week. Next week is Veterans Day, so Giri is not going to have a competitive programming team lecture. But I might still do one, continuing this topic, because there's a couple other things I want to show you guys.
Well, but you will have a meeting on Wednesday and Friday next week.
Yes, so Wednesday, David's still going to have a Wednesday meeting for beginners. He's still going over trees, correct?
No, graphs.
Oh, you're going to be doing graphs now? Cool.
Yeah.
So now he's going to be going over graphs. So yeah, highly recommend doing that, and that's on every single Wednesday. It would have finished before December starts.
Okay, and what are you going to do Friday? Next Friday?
Yeah, so since Gary's not going to give a lecture, I can't really go over what he taught because he's not going to teach. So I might just continue this, but with a slightly different problem. Huh?
We should probably do the traveling salesman.
The traveling salesman? Yeah, I'll talk about that.
Was it the Drummond Ford algorithm?
No, the traveling salesman's an NP hard problem. So it's really hard to solve. Yeah, so it's actually extremely hard, yeah. But Bellman Ford is
So
for...
you're saying you might do traveling salesman next Friday?
There's a way of doing it with sequences, yes.
Explain the differences, explain. Sorry.
Oh, Bellman Ford and traveling salesman?
So make sure.
Bellman Ford is to find the shortest path from two sources with negative weights. The edge cost could be negative.
I remember that.
Traveling salesman is you want to visit every node only once, and you want to start and finish at the same node.
Wait, wouldn't you have a single source shortest path?
Yeah, I said that, right?
Yeah, so between one node to every other.
Oh, to every other. Okay, my bad.
Every other.
My bad. But it allows negative weights. That's a special thing about that algorithm.
Traveling salesman, would you not just have like, I don't know, like the forward checking? Is that possible for a traveling salesman?
The what?
Can you do like forward checking, like going forward to see like, how to say like?
So it's actually the same algorithm, but you want to check if there is an edge between U and V.
Oh.
To see if you could go from currently U to V. Yeah.
The reason why it's so different from that is because you're going from, like, you're taking one point to another point. So the problem is, like, because you have to go back to the same point, it changes the whole situation. So you can't really use lectures of those ones.
Yeah.
Oh, so you can't add the heuristic.
Yeah. You want to visit every node at least once, except the start and end. You want to start at one node and end at that same node. So you want to do a tour.
Yeah. Yeah, this is different. It's like, it's a tour versus a path.
Yeah, yeah.
How do you adapt this to fit the problem you mentioned when with the one on Nico?
You need to keep first off, that problem doesn't work because that's still brute force. Like I said, that problem you need to do.
Find a formula.
Yeah, you need to find the formula. But if you want to do it in order, because as you can see, this would have given you 1, 2, 3, 1, 3, 2. So far, that's an order. But then it goes 2, 1, 3, 3, 1, 2. That's no longer an order. The order version would be 2, 1, 3, 2, 3, 1.
Yes, and how do you modify?
You use a set. You use a set, and instead of calling like visit of V, you do like val at V is equal to count. I can show you, I have the code. Yeah. Yeah, I know, I'll be there soon. Okay, so now David wants to come up and talk about something that he's gonna be doing today. Yeah.
Well, you're not erasing that yet.
No, yeah, I'm not gonna erase it yet. You can take a photo.
Yeah, take a photo, guys.
You can end the live stream as well.
Oh, I can end it?
Yeah.
It's this button, right?
Yeah, I'll click it for you.
Okay. So, one. What's up? Sorry. You finished.
No, that's cool.
Okay, well, really quick. After the Figma workshop, I think, what time does it end?
Like 5 to 6:30 maybe?
Okay, so at 6:30, I'm planning on having a little informal get together on solving LeetCode problems that have been pushed on the server. So if you guys are interested, pull up. No, it's just gonna be you guys. There's no competition. It's just solve LeetCode problems that you guys want to solve, and you guys work on it together and explain what you think is the best approach.
Okay.
Online is
Hybrid, right?
Huh?
It's gonna be hybrid, both in person and online. Yeah.
You know what? How are we gonna do that? Like
We
over
can
the
just talk to them.
code dojo?
Yeah.
Okay, I'm gonna have the Discord channel, voice chat. It's gonna be that. I'm thinking PG6.
PG6, either the current room for Figma, so 116, or we just walk around
I-
somewhere else.
Yeah, we can go to 114.
112 maybe.
Yeah, 115. I like that room.
Anywhere that's open.
Yeah, in PG6.
What time?
6:30. So after the Figma workshop ends.
Like when though? Today or no? Or
Today, yeah, today.
Yeah. Oh,
That's today.
today?
That's today.
I understood Wednesday.
No. Wednesday is my lecture,
Oh.
and this Friday is this informal, impromptu. So it's new. I just kind of pushed it there. If you can't come, it's fine. But yeah, I'll be having that. It's gonna be, I guess, hybrid because
Yeah.
I'm gonna be on the coding dojo. So it's hour and a half. I think we're gonna spend.
Yeah. We've sent out a whole bunch of trees questions, so we can go through
What
all.
was the building again?
Huh?
through all
The
them.
room? Under what?
PG6. It's
Go to 116.
116 is the Figma.
Yeah, so we'll most likely be there. And
Yeah.
we can move
And I'll just guide you guys to the room if you're in the workshop, and in the room we're at, I'm gonna on the Discord say, hey, we're in room so and so.
Hey, when are you guys coming back next year? When exactly?
Oh, we actually start pretty early. So every semester.
Yeah.
You're talking about like our lectures, right?
Yeah.
Yeah, every semester we start pretty early because the Giri, he wants to start as soon as possible to prepare us for competitions.
How soon?
Yeah.
Probably the first week of school, first or
Yeah.
second week.
Okay.
But you have
Yeah,
I will
just
be
to-
graduating, so it doesn't matter. I'll still show up regardless.
Show up,
cool.
yeah, show
that's
up.
Awesome, yeah.
Yeah.
To get better.
like all that everything they've covered is also on the YouTube channel.
Yeah.
I'm gonna watch all of it. I'm gonna watch all of it.
Yeah.
Hey, I have a question. When do actual competitions happen? Because I'm just
So-
here for, learning.
Yeah.
Yeah,
so
yeah.
we did one last
Yeah.
year, I think like around March or something.
Yeah.
We think the next competition is during next semester.
Yeah. Wasn't there gonna be one this November?
There was to be one this November, but I think it got canceled and moved to March.
Oh, really?
Yeah.
Oh, so there was gonna be one this November, and now,
Yeah.
No.
Plus, and if you compete, you get a scholarship.
yeah.
So.
Well, if you're in the team, you get a scholarship for being
yeah, so if you
in the
compete, you're
team.
part of the team.
Okay. Wait, where's my scholarship?
You didn't get a scholarship?
I know. I did that competition.
You didn't get like $800 in your income?
Did you?
Yeah.
He can't tell you about this.
Dear God.
Yeah, but
I need to sue. I'm gonna sue. I've completed one problem. I think we beat the worst team in Clemson. I felt really good about that.
My boy right here.
Yeah, exactly. We beat Clemson. But yeah, thank you for coming to this review lecture, and hope to see you at the Figma and the Lead Code